the second method, that is the electrolytic reduction of alumina. Now in this method, electrolysis of molten mixture of alumina whose melting point is more than 2000 degrees Celsius is done in a steel tank. Now this is the steel tank. In this tank, this is steel tank. The inner lining of the steel tank is done by a graphite layer. So inner lining is made by graphite layer. This line does the work of cathode. So it is act as a cathode. So this is the inner lining of the tank, which is acts as a cathode. Then a set of graphite rods dipped in a molten electrolyte solution, they work as an anode. So you can see here, these are the graphite rods immersed. This is the electrolytic solution. So they act as a anode. Then a mixture of cryolite and fluorspar CF2 are added in this mixture. Why? Because the melting point will be decreased up to 1000 degrees Celsius, because alumina melting point is more than 2000 degrees Celsius. Therefore the mixture of cryolite Na3Alf6 and CaF2 fluorspar, this mixture is added to lower the melting point up to 1000 degrees Celsius. So when electrolysis started, aluminum is deposited on cathode. So this is the cathode, means aluminum will deposit here. Yes, aluminum will deposit cathode, and by passing electric current, molten aluminum being heavier than the electrolyte. So this iron is heavy than electrolyte solution. That's why it settle at the bottom of the tank, and it is taken out from there from time to time. So oxygen gas is liberated at anode, and oxygen O2 gas is liberated at anode. So this is the total process. So here anode reaction and cathode reaction take place. So anode reaction 2O to form O2 plus 4 electrons, oxidation take place, and cathode here aluminum reduction take place. So this is the total process that is called as a electrolytic reduction of alumina. Just listen the more information about the electrolysis.
Step 2. Electrolytic reduction of alumina. Electrolytic reduction or electrolysis is carried out in a large steel tank which has a graphite lining on the inner side. This lining acts as the cathode. There is a set of carbon rods or graphite rods dipped in the molten electrolyte, that is alumina. Dipped in the molten electrolyte, that is alumina, which act as anode. Pure alumina has a high melting point which is greater than 2000 degrees Celsius. In order to lower the melting point, pure alumina is mixed with molten cryolite, that is Na3Alf6, and fluorspar, that is CaF2, and then melted in the steel tank. Thus, electrolysis can be carried out at about 1000 degrees Celsius. Now, let us see the reactions taking place during the electrolysis of alumina. On passing an electric current, electrolysis of alumina takes place. During electrolysis, the negatively charged oxide ions are attracted to the anode. Here, they lose electrons to form oxygen gas. The positive aluminium ions are attracted to the cathode. Here, they gain electrons to form the molten aluminium metal. Molten aluminium is denser than the electrolyte, hence is collected at the bottom of the tank. It has to be removed from time to time. Oxygen gas liberated at the anode has a tendency to react with the carbon anode itself to form carbon dioxide gas. So the carbon anodes are gradually oxidized or consumed during the electrolysis, and therefore they have to be replaced from time to time. Now let us discuss the extraction of moderately reactive metals. Extraction of moderately reactive metals. Metals.
Now the second part, that is the extraction of medium reactive metals. So the metals in the middle of the reactivity series like iron, zinc, lead, copper, they are medium reactive, and usually they occur in the form of their sulfide salts or carbonates. So here two methods are done, that is first roasting and calcination. Means the sulfide ore are strongly heated in air to transform them into oxide, that is called as a roasting. And second, calcination means carbonate ores are strongly heated in a limited supply of air to transform them into oxide, that is also called calcination. So roasting and calcination are the two methods.
Placed in the middle of the reactivity series. That is, zinc, iron, lead are moderately reactive. These metals are usually present in the form of their sulfides or carbonates. It is easier to obtain a metal from its metal oxide by reduction than from its metal sulfides or metal carbonates. Therefore, metal sulfides or metal carbonates are first converted to metal oxides by processes like roasting or calcination. Roasting and calcination. In the method of roasting, the sulfide ore is heated strongly in the presence of excess of air to convert it into oxide. For example, zinc occurs in the form of zinc sulfide in its ore, zinc blende. Zinc sulfide, when heated strongly in the presence of air, can be converted to zinc oxide. Carbonate ores can be converted to metal oxides by a process known as calcination. In this method, the carbonate ore is heated strongly in the presence of limited supply of air. Zinc also occurs as zinc carbonate in its ore, calamine. Zinc carbonate, when heated strongly in the presence of limited supply of air, gets converted to zinc oxide. The metal oxide so obtained by calcination or roasting is reduced to zinc by reducing agents like carbon. Besides carbon, highly reactive metals like sodium, calcium, and aluminium are used as reducing agents to obtain the metal from the metal oxide. These metals can be used as they can displace the moderately reactive metal from its compound. For example, manganese metal is obtained from its oxide when it is ignited with aluminium powder. Here, aluminium acts as a reducing agent. In this reaction, aluminium is oxidized to aluminium oxide and manganese dioxide is reduced to manganese. It is an exothermic reaction and the metal manganese produced is in the molten state. This is also a displacement reaction in which manganese is displaced by aluminium. Another such type of reaction using aluminium as a reducing agent is the thermite reaction. Here, iron oxide is reduced by aluminium powder to produce the metal iron in the molten state. This property of reduction of aluminium is used in thermite welding for joining broken pieces of railway tracks. The molten iron formed from the reaction between iron oxide and aluminium is poured between the broken rails to weld or join them. Now let us discuss the extraction methods used for less reactive metals. Extraction of less reactive metal.
Then the last, that is the extraction of less reactive metal. So the metals elements at the bottom of the reactivity series They are less reactive. And they are found in a free state in nature. For example, gold, silver, platinum. Yes. So copper is obtained from copper sulfide or just by heating in air. Means copper sulfide when heated in air to form copper oxide and sulfur dioxide gas is given. Then copper oxide react with the copper sulfide again to form copper and sulfur dioxide gas is given out.
Metals placed at the bottom of the reactivity series are the least reactive, for example, copper, silver, and gold. These metals can be extracted from their oxide or sulfide ore by just heating them in air. Copper is found as copper sulfide in its ore, copper glans. When the copper sulfide ore is heated in air, part of the copper sulfide is oxidized to copper oxide. Sulfur dioxide is also formed in the reaction. When the supply of air for heating is stopped, the copper dioxide formed earlier reacts with the copper sulfide to form copper metal and sulfur dioxide. Similarly, mercury is obtained from its ore, cinnabar. When the ore is heated in air, mercury sulfide is first converted to mercury oxide and sulfur dioxide. When this mercury oxide is further heated, it gets reduced to mercury. Metals obtained after reduction processes may contain impurities. The process of purifying impure metals is called refining. Refining of metals. The most widely used method of refining metals is electrolytic refining. In this process, the impure metal is connected at the positive terminal of the battery and a thin strip of pure metal is connected at the negative terminal. The water-soluble salt of the metal to be refined is taken as the electrolyte. On passing an electric current, the impure metal dissolves from the anode and goes into the electrolyte. The metal from the electrolyte deposits on the cathode. The soluble impurities present in the impure metal go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. In this way, the pure metal is produced at the cathode. What is meant by corrosion of metals?
Now this is the total process of extraction of metal. Our last topic, that is the corrosion of metals. So corrosion of metals means that is the formation of or degradation of metals by the chemical reaction with air, water and other gases. That is called as a corrosion. You have seen iron reacts with the moist air and deposit of reddish substance on its surface, that is Fe2O3H2O is formed, that is called as a rust. Similarly, carbon dioxide in moist air reacts with the surface of copper vessel. Copper loses its luster due to formation of greenish layer of copper carbonate CuCO3 on its surface. This is called as a patination of copper. So let us study about the various methods of corrosion prevention, how it will be prevented.
You must have observed that iron objects, if remain unused for some time, get rusted. This process is called corrosion. Let us know more about corrosion of metals. The degradation of a metal by the action of air, moisture, or acids is called corrosion. When an iron object corrodes, a red-brown layer is formed on the metal surface. This is called rust. We have seen old iron bars of buildings and old vehicles getting rusted. It is found that every year, out of newly fabricated iron articles in the world, about 25% of iron gets rusted and causes large financial losses. Copper vessels also lose their shine when they are not cleaned for a long time or when they are left exposed to air for some time. Copper reacts slowly with carbon dioxide and water from the air to form a green coating. This coat is due to the formation of copper carbonate on the copper surface. This is called patination of copper. When silver articles, ornaments, or idols are exposed to air, they lose their shine and become black. This is because silver reacts with the compounds of sulfur, such as hydrogen sulfide, and forms a black coat of silver sulfide. The metals gold and platinum are resistant to corrosion. They are not affected by air, water vapor, and other gases in the atmosphere. This is the reason they always glitter. Aluminium metal begins to corrode quickly when it comes in contact with the moist air. It reacts with the moist air to form a layer of aluminium oxide on the aluminium. Let us now discuss the methods to prevent corrosion. Prevention of corrosion. Corrosion can be prevented if the contact between the metal surface and oxygen or moisture is cut off. The most common method of preventing corrosion is to coat the metal surface with paint, varnish, grease, or oil. Metal articles, bicycles, iron doors and windows can be protected in this way. Another method is to fix a layer of some substance on the metal surface so that the contact of the metal with moisture and oxygen in the air is prevented and no reaction would occur between them. Can we permanently prevent the rusting of articles by applying a layer of paint on its surface? We cannot protect the articles permanently from rusting by painting them. This method is useful only as a temporary solution. If there is a scratch on the painted surface, because of which a small surface of the metal becomes exposed to air, then the process of rusting starts below the layer of the paint. You may have seen that new iron sheets appear shiny. Why is it so? This is because the iron sheets have been coated with another layer made of a non-corrosionable metal. This prevents the corrosion of the iron sheet. Corrosion can be prevented by putting a layer of a non-corrosionable metal on a corrosionable metal. Let us discuss some of these methods. Galvanization. Galvanization. Rusting of iron can be prevented by coating the surface of iron or steel by zinc. This process is called galvanization. Iron nails, pins, and iron pipes are galvanized to prevent them from rusting. The iron object undergoes various stages during the process of galvanization. They are caustic cleaning, rinsing, pickling. Again rinsing, dipping the object in flux solution. Then drying the object. Finally, the object is dipped in molten zinc, then cooled and dried to obtain the galvanized iron object. Why is zinc used in the process of galvanization? Zinc, being more electropositive than iron, is more easily oxidized than iron. In this way, the zinc metal corrodes first. Is galvanization a permanent solution to prevent corrosion? No, it is not so. When the galvanized object is exposed to few rainy seasons, the zinc layer goes away and the inner iron gets exposed. The iron then starts rusting. Let us understand the process of tinning. Tinning. Tinning is another method used to prevent corrosion. It is also called as kalai. Cooking vessels made of copper or brass often develop a greenish coating over them due to corrosion. This layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. If copper or brass vessels are coated with a layer of tin, the vessels can be protected from corroding. What is anodizing? Let us understand this. Anodizing. Metals like copper and aluminium can be coated with a thin, strong film of oxide on them by the process of electrolysis. This oxide film protects the metal surface from further oxidation. Anodizing is one such technique used for this purpose. In this technique, the electrolyte used is dilute sulfuric acid. The aluminium or copper article is used as an anode, and a carbon rod is used as the cathode. During electrolysis, oxygen, which is produced at the anode, combines with aluminium, resulting in the formation of a thin film of aluminium oxide on the surface of the anode. This prevents further oxidation. This protection can be further increased by making the oxide layer thicker during anodizing. Electroplating. We are familiar with gold-plated jewelry and silver-plated spoons. This is done by a process called electroplating, where a metal surface is plated by another metal by the process of electrolysis. In this method, the article made of the more reactive metal is used as the cathode, while the bar of the less reactive metal is used as the anode. The salt of the less reactive metal is used as the electrolyte. Alloying. Alloying is another method that is used to prevent corrosion. This is the reason many metallic substances that we use presently are in the form of alloys. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. Stainless steel is an alloy of 74% iron with 18% chromium and 8% carbon. Stainless steel does not get stained with air or water and does not rust. Bronze is an alloy formed from 90% copper and 10% tin. Bronze statues are not affected by sun and rain. In recent times, stainless steel, which is made from 82% iron and 18% chromium, is one of the alloys used for making coins. These alloys have anti-corrosion properties. They are hard and are resistant to wear and tear. Duralumin is an alloy of aluminium. Duralumin is light in weight but strong enough to make parts of a pressure cooker and also of an aircraft. Tungsten steel contains iron and small amounts of tungsten and carbon. It is very hard alloy and hence used to manufacture high-speed cutting tools. Manganese steel is also a very tough alloy. It is used to manufacture rock drills. It contains traces of manganese along with the main metal iron. Brass is an alloy of copper and zinc. Brass is more malleable and more strong than copper. It is used to make cooking vessels, screws, nuts, bolts, and ornaments. Solder is an alloy of lead and tin. The melting point of it is low, so it is used for soldering or welding of electrical wires. If in an alloy, one of the metals is mercury, then the alloy is called an amalgam. For example, a solution of sodium metal in mercury metal is called sodium amalgam. Silver amalgam is used by dentists. It is used to fill cavities caused by tooth decay. Gold amalgam is used for the extraction of gold. Zinc amalgam is used in the Clemmensen reduction of ketones.